All right, I think we're live. I hope we're
Yes,
live. All
it
right,
says we are live.
we are live. Awesome. Excellent. So I am Eric DeAndrea. I'm with Red Hat. I am here with Maria, also from Red Hat. Going to talk to us a little bit about bungee jumping into Quarkus. I've never been bungee jumping, but I'm super excited to learn about it. So,
Thank you.
all right, take it away, Maria.
Hi. So, first, a disclaimer because, most of the team behind Quarkus comes from Red Hat. So people think that I am from the Quarkus team or I'm related to them somehow. It's true, I work for Red Hat, but I'm not in the Quarkus team. I know some people, I may have talked to some people in the Quarkus team, but I have nothing to do with Quarkus team, Quarkus development or anything. So I come to this talk not as a developer of Quarkus, but as a user of Quarkus, as a developer that uses Quarkus, not a developer that develops Quarkus. So I may not be completely accurate. I may not have all the answers you may have. I may not know everything. I just know what I have been hitting my head against and what I have discovered during this time working with Quarkus. So first thing, a bit introduction about me. Well, I have been working with open source for a very long time, and I come from the geospatial world, so I have a background in maps and location intelligence and things like that. And then in 2019, I joined Red Hat, and there I joined the middleware department, and I work with Apache Camel, and I work with the visual editors for Apache Camel. So you are able not only to write an integration or write the code for this framework manually, but you also are able to create the code visually in a low code, no code way. So in it was 2020, it was 2 years ago already. At some point in 2020, we decided to start a new project to have this Kauto.io that is going to be very visual. You can drag and drop things and you can build entire integrations to orchestrate architectures without having to write a single line of code. That's the main focus and the main idea. If you want to write the code, you can also open the tab and write code or see the code that is being generated. And the thing is, we started from scratch. We had no legacy, anything to drag with us. We wanted to have everything in a clean slate, everything clean, new architecture, new approaches. So we were able to use the technologies we wanted and the latest technologies we wanted. And that meant that at the time I was still working with Java version 8, 9-ish, maybe 11-ish. It was regular Java, it was imperative, it was war deployed on a Tomcat, blah, blah, blah. That's the world I was coming from. And then I decided I'm going to use everything new. I'm going to use JDK 17, which at the time was not even stable. It was a beta. So things were not really, libraries were not still on JDK 17. I wanted to use Quarkus because I have read a lot of things about Quarkus, but I didn't really know what Quarkus was at the time. I wanted to change from imperative to reactive. I wanted to have native deployment and wanted to have everything that was cloud native and all these amazing buzzwords that they make sense. But, when you start a new project, you say, oh, I want to have all these nice things and I have nothing, I have no package, I have no luggage that is dragging me. I can do whatever I want. So I'm going to start with Quarkus. And like many developers that start with new frameworks and technologies, I didn't read much the documentation, which is something I highly encourage you to do if you're going to start with a new framework, being Quarkus or whatever. Quarkus has a very, very nice documentation and tutorials, and it's very well explained, everything. But, you just want to start getting your hands dirty and you just want to start developing and see things happening and not stop reading documentation. So that was the first mistake I made. But let's see. What is Quarkus? The Java way of working, the traditional Java way of working is the idea is that you create this jar or war package or whatever package. You create a package, and then when you write the code in Java, it gets compiled to a intermediate byte code that the Java virtual machine understands. So you deploy the jar, and then it reads everything, and it loads the classes, and you have a class path. You can even have dynamic class paths, so you can have you can add new dependencies and on the fly while the program is running. Like I added a new plugin to my Eclipse, and then it loads the classes from this jar, and then you have a lot of nice things, and it runs everywhere, and it has a lot of it's very dynamic, Java, but it has disadvantages. Like, it's not like if you write a script in Bash and you say run it and it runs. Usually Java has the fame of being a bit slower, has more memory footprint. So there has been attempts like GraalVM, Micronaut to speed up this. So GraalVM does this ahead of time compilation. So you work, instead of on a very dynamic and open world, you start working on a closed world, which means on build time, you have all the information you're going to have. So you are not going to be able to plug in things later dynamically. You already have all the classes you're going to use already on build time. And that gives the compiler certain advantages, because then you can optimize, and then you can, for example, remove parts of the code that you are not really going to use, making the memory footprint smaller. And also it can reorder things and do a lot of things to speed up the starting time. So Quarkus is using this philosophy, and you can use GraalVM with Quarkus. And the idea is that it does a lot of things that usually traditionally happened on runtime in the normal Java virtual machine. Now it does all those things on build time. So the package that is generated is much more optimized, and it's faster, and it has a lower memory footprint. If there is some class, for example, you have a dependency, and from that dependency you're going to use only 3 classes from 30 classes that dependency brings. On the final package, you're not going to have the 30 classes. You're only going to have these 3 classes you're going to use. So the package is smaller, the memory footprint is smaller. It's faster also accessing things, because the less code, it's faster doing things. So Quarkus, it's the slogan they use, it's supersonic, subatomic Java, because it's very fast, supersonic, and subatomic. It's very small memory footprint and small size of the package. And you can know this about Quarkus the same way I did, just by reading the web page, understanding more or less what they are doing, and then you start developing for Quarkus. This is more like a list I created of the pros and cons I found very roughly. Part of the things that I found, maybe some of the cons are because I didn't read the proper documentation, or I didn't find the proper way of doing things. Maybe some of the pros is because I'm very pro something, but will not work for your use case. But I think this is a very good, quick list. So some of the pros, as I said, this is incredibly fast. The problem of running something like a bash script that you just run and it runs, it happens with Quarkus. So you click run. I think there was a call from, there was a talk from Holly Cummins that said that it was faster than lighting a LED bulb. It's fast. It's microseconds, really, really fast. Also, it uses all the standards. What do I mean with it uses all the standards? So when you're working, for example, with Spring, you have this auto-wired, you have all these annotations you use, but they are Spring specific. So if you want to move to another framework, you have to rewrite parts of the code, because your code, if you no longer uses Spring, then you are missing those annotations. You need a different annotation to explain the same thing, the same functionality you want. But Quarkus has been very careful on using only standard specifications. So, for example, it uses the JPA, it uses the JTA, it uses follows the Micronaut specification. It uses all the proper standard Java way of implementing code, way of writing code. So if in the future you want or need to change to another framework that is not Quarkus, something else, it will be easier as long as that other framework is also standard. Of course, if it's a framework that doesn't use the standard, it's no use. But you can change between frameworks that uses the same standard. And not being tied to a specific framework is a great advantage, because today I'm very happy with Quarkus. Tomorrow I have no idea what's going to come next. And at least for me, knowing that I can jump to another framework easily, it gives me peace of mind. Also, the dependency management is very easy. Why I say this? Because when you move to, can I do this? Yes, this is a website of Quarkus. And well, it has, as I said, it has a lot of information. It has a lot of documentation. It's very well contained, this webpage. You can click on Start Coding. And if my network responds, yes, there is here a list of libraries that I can use, that I can, for example, search for. I want to manage database. There is no database. I don't know. Messaging. I have different libraries that I can use for messaging, depending on what are my specification, my requirements. And if I generate application, I can download the zip, blah, blah, blah. But what I want to show you is that there's a lot of libraries that are specifically built or rebuilt or rewritten for Quarkus that uses all these advantages that make them very fast, low memory footprint, uses all the standard specifications, blah, blah, blah. So you can easily plug in those libraries and it's going to work. It's true, this is kind of opinionated. You can use other libraries that are not from the Quarkus universe, but if you use these ones, it's going to work, and it's going to work in the Quarkus way. If you use external libraries, they're also probably going to work with, now later I'm going to tell you about the cons of using Quarkus, but it's just that this, it's similar to Spring when you add the Spring Hibernate, Spring, Spring database, something, blah, blah, blah. That if you match properly the versions, it's going to work. Also, Quarkus is very focused on Kubernetes and the cloud world. So it generated the custom resource definitions to deploy the things. You also have a command line Quarkus, something, I don't remember how it was, that deploys directly to a cluster. You can generate the native builds. So if you are into the cloud, if you are not into the cloud world, you can use it anyway. But if you are into the cloud world, everything is very easy and prepared to be able to deploy to the cloud and manage in the cloud and watch in the cloud, and it makes your life easier. At least it made it for me. Quarkus also has great design patterns. You don't have to follow them, but for your own sanity, it makes sense to follow them. For example, they tell you to create resources, services, and push you a bit into the hexagonal architecture and push you a bit into the reactive way of working. You can also not do this, but it gently pushes you to this kind of good design patterns that, for your own sanity, I recommend to follow. And it also has the live coding, which means you can run a command line that is Maven, Quarkus, dev, blah, blah, blah. And it runs. And if you modify the source code, it detects the changes. And in real time, it reveals them and adds them to the running program, so you can test directly what is happening. So you can search for any of these talks where people are building a service and then they change the response, and automatically the response is different when you click on the browser, because it's constantly changing in real time the code, which is nice because, sometimes when you run a Java, you're developing Java, if you have to rebuild and then run and blah, 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 sometimes it's slow. But Quark is so fast that you can do this live coding and rebuild in real time. Also, I added the debug in native mode because on my first version of this talk, this was in the cons. I wasn't able to debug in native mode, which was annoying for me because I had a couple of bugs that didn't happen in Java mode, but in native mode. And I didn't know how to hunt those bugs. But now they have changed that, and you can use the same IDE for debugging in native mode. So you're running the native mode, but you're debugging on the Java code. What is the native mode? You can not only build to a jar file or WAR file or whatever, but you can also build into directly as a native application of your operating system. That means that, for example, if you are running, it's faster than running through GraalVM or the normal Java JVM. It doesn't matter. It's faster, the native mode. And it's also useful, for example, if you want to be Knative, because if you are in the cluster, you're having a pod that needs to have the Java virtual machine and then run the jar file, and then maybe you're trying to make this serverless. Maybe you're just wasting 10, 20, 50 milliseconds in spinning up this service in Java. But even if it's just 50 milliseconds, it's 50 milliseconds you are adding to the code. If you can do it faster in native mode, directly on the executable, why not? Then in the cons, it's a fancy state of the art. Well, it's true that it's less and less fancy state of the art, something experimental, and is more established, but it's still something that is evolving very quickly. But you can't imagine how quickly it's evolving. It's continuously adding new features, new libraries, new things that in the past year, if you see the logs of the latest releases, there are a lot of changes. Maybe not for the normal developer. If you're developing and you have your project already established, well, they are adding new things, I'm not using them, that's fine. But they are constantly adding new things, and they're constantly adding new libraries, and they're constantly adding new speeding up and improving the optimization. But this also has a problem because they are adding a lot of new things. If you needed one of those things that they are adding before they add them, well, that may be a problem. Although that means that you can also help in developing whatever you are still missing, which is very few things at this point. But there may be some libraries, something that is maybe some niche thing that is still not there in Quarkus. Well, you can help make that thing go into Quarkus, and that means that you're going to control and decide how that thing goes into Quarkus because you are doing that. So it's kind of a pro-con. It has all the fancy new technologies. It has all the fancy new things. Some niche things may not be there yet, but you can add them because it's open source. And the thing that people find most annoying about this is, well, I told you we work in a closed world where you have all the information on build time. So that means you cannot use reflection. You cannot load classes dynamically and then call a function in this class that you build you create the name of the function on real time and then call it by reflection. You cannot do this kind of dark magic, which on one hand is okay. People that use this may find this annoying because they have to find another way of implementing the same things. On the other hand is, but seriously, how many people use reflection in their day-to-day life that they cannot do it somehow in a different way? So the list of pros keeps growing, the list of cons gets shrinking. And now I'm going to talk to you a bit about my experience in using Quarkus. The first thing you should know is that Quarkus, when you run a Quarkus application, Maven Quarkus .dev, it has a dev console, this dashboard, that has a lot of information. This is only on development time. If you run it in native mode or in production mode, you will not have this developer console, but on development time, you have this console. And this console has a lot of things. Some things may not be useful for you, but some other things may be useful. Like, I want to know how many beans are loaded. Maybe I can detect something that some memory leaks. Maybe I want to check the configuration or even edit the configuration, because what happens if instead of a 1, it's a 3 in this attribute in the configuration? Or I can check things like the health of small Rai, or any of these things that, yes, you can find them with an IDE, but they are already here on the developer console and very easy to reach and very easy to explore. So I find this very useful because maybe even if it's just to check that you're not doing anything weird, that your code is not doing anything weird, that everything is how it should be, I think this is very useful. Then one of the first things that I did, so I showed you that when you can go to the website of Quarkus and you can select the dependencies you want for your project, and then it generates a hello world. You can download the zip, or you can use the command line to generate this. So one of the things I did, the first things I did is, of course, my project is going to be complex. It's not going to be a single monolith. It's going to be a Maven multi-project. I'm going to put the domain here. I'm going to put the loading the catalogs here. I'm going to put the different DSLs we are going to process in the editor here, and they are in different projects. So this is going to be a Maven multi-project. I created the Maven multi-project, and it worked perfectly fine when I ran it with the normal Java jar command line. But when I compiled in native, it didn't work. And it threw me some weird errors. I was hunting those errors. I didn't know what's happening. If this worked in my hello world, why is it not working in the multi-project? Well, as I told you, one of the things that Quarkus does when you compile is removing everything that is not going to be needed. So I have my first project. It had 10 classes. They call each other. Maybe 5 of them were calling each other. The other 5 were for the following, consequently, projects. So when Quarkus did the build of the first project, it removes all those 5 classes that no one was using inside that project. So when it was included as a dependency for the next project, instead of 10 classes, I only had 5. Why? Because that's not the way you should do it. The native compilation should be only in the last one. So you have all the dependencies, big, fat dependencies, calling one another, the chain of dependencies on the projects. And on the last one is the last one is the one that has all the information to remove the classes that are not going to be used, to remove the functions that are not going to be used, to optimize, to classify, to change things. But I didn't realize that at the moment. So if you're going to use multi-project Maven, don't be me and make sure that all the native compilation is only in the last step, in the last project. Then once I finished that, I realized, okay, now it's working, but some pins are missing in native mode. Why? I already did the compilation, the pins are on the dependencies. Why, when I compile the last piece in native, some pins are missing if they are there? And I'm making sure that I'm dragging all the dependencies to the end. Well, because Quarkus was not considering beans from the dependencies, only considering the beans on the last project. Because it was very eager to remove things. How do you fix that? Well, you just add this Yandex index thing to your Maven.pom file, which the only thing it does is list all the beans available in each of the dependencies. So Quarkus don't miss any of them or don't forget any of them in the way of doing the build native. There are more approaches. There is some Stack Overflows threads on what to do when my beans are missing, blah, blah, blah. You don't need to worry about them. Just add the Yandex index and this fixes it. Why would you need anything else? And I was talking about beans. I was talking about dependency injection. And I was talking about using standards. So it's true, Quarkus uses the Jakarta Context and Dependency Injection 2.0 standard. And you may notice that it has, if you come from the Spring world, I come from the Spring world, that's why I am using those examples. You will notice there are more fine-grained dependency injection than Spring, or at least the Spring I used to use. So I think it's very nice because, as I said, this code, if you use other framework that uses the Jakarta Context and Dependency Injection 2.0, this code works, and it should work the same way. So if it says application scope, or if it says singleton, or dependent, or session scope, they always mean the same in all the frameworks that use this standard. So you don't have to rewrite code if you, at a later stage, have to move to some other framework or library. Also, as this is a closed world again, it fills the beans and it knows which bean goes where and who is going to auto-wire what or inject what on build time, which means on runtime, it doesn't have to start searching who is the class that can fit here, that is a bean, blah, blah, blah. No, no, no. It's already done in build time. It's this one, done faster. But that also means that on build time, you may get errors like, I can't find a bean of this class, or I found two beans that may fit here. So they are build time errors. So that means you detect the error faster, earlier, which is another good thing. And also note the at startup annotation. That's another annotation that is a standard generic annotation. And it also means that, well, this is a class that gets created at startup. You don't have to wait for it to be called by someone else, blah, blah, blah. And again, this is everything is standard. So if you change to another framework that uses the same standard, every framework should use the same standard because it's their standard. But if you change, it will have the same meaning. It will behave the same or should behave the same, more or less. If you need to, yes, if you need to inject more than one, I mean, you can have, as this is build time, you can have like you see on the second example, you can have one function injecting more than one bean at the same time, because why not? You can inject. You don't need a getter and a setter for each different bean as we are used to in other frameworks, because this is build time. Quarkus knows best. You can write it like this. Quarkus will know if it's more optimized to do everything at the same time or in different functions or whatever. You just tell, I want to inject this. That's it. And as you can see, you can also inject a list of things. I think it's, yes, the instance, blah, 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 is you can inject more than once. And I was doing a lot of Marshall and marshalling because, well, as I said, I was working with editor that works with a specific domain-specific language from Camel, and then you have to parse and understand that domain-specific language to be able to visualize it, and then you have to do certain things and then convert the visualization to this language again. So there was a lot of Marshall and unmarshalling, which is good, because that's something Java does very good. But at some point, I realized that the polymorphic unmarshalling, so when you are when the unmarshalling can be one or other classes, and you have to decide that more or less on runtime, that was not very fine-tuned. I have to check again, but I have to say that this was complex for me to discover why it was not working. And in the end, I had to do this unmarshalling by hand. And I want you to note the register for reflection on the JSON B deserializer class. Why? I told you that Quarkus removes a lot of classes and functions that you're not going to use. What does it mean that you're not going to use? Well, no one is calling them. If no one is calling them, they are not going to be used at any time. Well, but this JSON deserializer, they are not. This is not explicitly called at any time. So I need to tell Quarkus, yes, I know this is not explicitly used anywhere. You want to delete it. You think this is trash. You think this is garbage. You think this is memory footprint that you're not going to use. Believe me, it is not. So register for reflection means don't remove it, please. At some point, someone is going to call it, even if you don't believe me. And these are the two things that, these are the two most complex things that I found in Quarkus, that I had to do the polymorphic and Marshall by hand, and that I had to tell Quarkus to not remove this class. So you can imagine, if this is one of my biggest worries, working with Quarkus was nice, easy. Then don't be me. Read the documentation, please, and make sure to not only understand how Reactive works in Quarkus, but also that everything is reactive here, unless explicitly stated otherwise. So this is me being stupid. I was not, I didn't have the change of mind that everything is reactive. I was still thinking imperative. Sometimes I thought, no, this is a call. It makes sense that it's reactive, but it didn't click in my head until a couple of months of working in Reactive. So please make sure everything is reactive. Do not do things on the main thread. If you need to do long calls, blocking calls, whatever, don't do it on the main thread. Always do promises, always do threading somehow in the reactive way. It uses Mutiny and Vertex, and follow the tutorials. Don't be like me. But what happens if my endpoint is returning a slow response or a stream? For example, I have an endpoint that returns the log of an Apache Camel integration that is running. A log is not something that you can reactively return and forget. It's a stream that is throwing lines and lines and lines and lines. So if you're doing this on the main thread, you are lost. Even if you're not doing this on the main thread, all the calls are processed on the main thread, so you are blocking something that shouldn't be blocking. Well, it's easy. Just add the add blocking, and then it knows that, yes, this is not reactive. I need to do this imperative. I'm not going to use the main thread of reactive. I'm going to run this somewhere else that is not going to block the rest of the application. Easy. You just read the documentation, know that there is a blocking annotation, works. Also, testing is very easy in Quarkus, or I find it very easy in Quarkus. And I strongly encourage you to do native testing too, because seriously, sometimes things, because you are working in that Java mindset, classic Java mindset, you do things wrong, it works in the Java JVM normal runtime, but it won't work on native mode. And here you can also see the test HTTP endpoint way of doing tests. This is testing an endpoint. I'm just calling an endpoint with a body that's an empty list, and it's going to return a list of things. And this is a classic test. It works, and it checks also that the HTTP call is working as expected with all the Marshall and marshalling from Java classes to the HTTP response and request. And it's very easy, at least for me. I find it very easy, and I need to seriously stress the need to do native testing. Then in Quarkus, if you know what are test containers, there's not much I can do for you here. Just tell you that we have smart test containers in Quarkus. So test containers are, for example, if you want to test against a Postgres database or whatever, you just tell your test class, well, use test container from Postgres, create this table, or use this SQL to populate the database, and it works. And it when you're testing, it spins up a Postgres, and you can test against that Postgres, or whatever. You can test maybe against a Mongo or whatever service you need. There are test containers for many types of services. And the thing is that Quarkus makes your life even easier because it automates the provisioning of services that you can configure quickly. Maybe instead of having to explicitly state things that are very default, you just say, okay, I need a Postgres database with this username, this password, go, and Quarkus does it. It also allows you to configure things in property files. It simplifies the test containers, and it spins up test containers even easier than the normal JUnit way of testing with test containers. And it also, for example, provides you with Kubernetes test servers, which for me was very nice, because one of the things we are doing with Kaoto, with this editor in Apache Camel, is deploy the custom resources that CamelK is going to grab to deploy integrations. So I didn't want to set up a cluster every time I want to test this and run the test. And no, you just tell Quarkus, spin up a Kubernetes cluster, and it does it. And then you can inject the Kubernetes client and do whatever you want with that. It's a very plain cluster. It doesn't have anything installed by default, but well, it's already there, and you know it's empty. So whatever you populate there is what you're going to use for the test. And another thing that I strongly encourage you to do is to keep Quarkus upgraded. Quarkus is very fast doing releases, and as I said, it's improving very quickly. So sometimes you may you don't want to be behind on the Quarkus version because things are improving very, very quickly. So this is something that happened to me. This was, I don't remember when was the date this happened. February. In February, I had a problem related to the config mapping. I had a very complex config mapping with classes, within lists, within classes, blah, blah, blah. And well, Quarkus community is very active, so it was quickly fixed. And I say, hey, perfect. So I just said, next Quarkus version, this is fixed. I can forget about this. I will just simplify my config file by now. And when I really need this, I just need to add it. But you know what happened? That I forgot to upgrade Quarkus later. So I was confused. Why is this not working? Well, at some point in July, I didn't upgrade Quarkus and it was failing again. It was like, yes, but I kind of remember I already fixed this. Why is this not fixed? Because I didn't upgrade Quarkus. So seriously, two things. Quarkus community is very active. So if you have any issue, it's maybe they won't fix it like as fast as this, but they will help you probably quick and give you an answer, or at least point to you to how to fix what you're having, the problem you're having. And second, keep Quarkus upgraded. It's so stupid that this morning, last week, I upgraded the version here on this slide to the latest Quarkus version. And a couple of hours ago, they say, oh, we have Quarkus 3.0.0 release candidate, flu, alpha, beta, blah, blah. I say, okay, then my slide is already old and I just created it. I cannot believe this. So upgrading Quarkus is very easy. It can be done with the Pendabot if you're using GitHub. It's just one number in your POM file, and all the dependencies of all the library dependencies that come from the list of, or most of the library dependencies that comes from the list that I show you, that when you select the dependencies to download the hello world, most of them are covered on the same version file. So it's very easy to keep this updated, and everything gets updated at the same time. Not all of them are updated at the same time, but most of the dependencies are covered by this number. So it will be stupid to do like me and not upgrade it. Now I have the Pendabot and that won't happen again. And this is what I have right now. 40 minutes. If someone has any questions, I see there is one question. You're muted.
Yep, that would have helped, right? Yep. Lots of, like we were talking about before the session started, there's lots of buttons here, and as like a kid in a candy store trying to refrain from pushing any buttons here. So, but I did end up pushing one that I muted myself. So yeah, there was one question here, and I know it went back earlier in your talk when you were talking about ARC and dependency injection, and I'm not sure. I read it one way, maybe you read it a different way. So is it possible to use the ARC as a standalone Java-based application as pure DI? I don't know if they mean like, is ARC something you could use outside of Quarkus? That's how I interpreted the question.
Yes, as far as I know, ARC is outside Quarkus. It's one of the libraries that are adapted to Quarkus, but outside Quarkus. But I'm not sure how smart it is to use dependency injection in a Java-based application if it's not a service, or if it's not something that maybe it makes sense. Why not? I'm going to shut down here because I tried to do that at some point in my life, a normal Java desktop application, scriptish, blah, 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 use dependency injection, and I thought this is overkill. So I don't know if the question goes from, can you use ARC in a desktop version of Java, or if you can use ARC outside Quarkus?
Yeah, I don't think you can
use.
I don't think you can use Arc outside of Quarkus. I think it's a CDI implementation specific for Quarkus.
I'm not sure. As I said, I'm not a Quarkus developer.
All right, the next question: could Quarkus's packaging and class removal introduce potential problems with possible reflection calls if done naively?
If you try to use reflection, I think it throws an error. So reflection is not allowed on Quarkus. If you try to use it, I think you will have a build error even. So you will know early. But if you are just, if it doesn't fail on build error because it's a weird way of using reflection that is not specifically calling the reflection method dot something something, then you may run into problems on runtime. But I think that most of the problems you will find are done on build time when building native. At least my experience is that Quarkus knows when something is wrong and it tells you.
Yeah. And I know Quarkus is pretty smart too about, like, for example, like marshaling to JSON is a pretty reflection intensive thing using something like Jackson or JSONB. But like when you're writing your REST endpoints using JAX-RS, if you have like an entity class as the return type, Quarkus is smart enough to understand that, hey, I need this, and you don't have to do anything as a developer. It'll figure it out automatically. But other things, like an example I think you showed, you had to tell Quarkus that, hey, don't throw this class away. It's actually needed.
Yeah, so if I go to that error, where was this error? Beep, beep, beep. It was a class not found error on runtime. So it's true. Not all of them were on build time, but most of them were on build time. I remember that the reflection, because I also was very keen on using reflection, was on build time most of the errors. So you will detect them early. The thing is, you have to change your mindset and think this is a closed world. This is I don't really need reflection. I can, whatever I need to do, I should be able to do it with any other design pattern that is not reflection. It's changing your mind.
But there's also, I know myself personally, I've run into times too where I'm using like a library where I don't own the source code, and I can't point the finger at them and say, hey, you used reflection, shame on you. So there's ways to get around that. I think it was like an Amazon like S3 or something library I was using, and it worked fine in JVM mode. But once we got to native, it was, okay, first we have to add this to the manifest, and then we got a little farther, and then we have to add that to the manifest. And finally we got through it after about an hour of, kind of going back and forth to get it to work.
But once you get used to writing code this way, and I think it's something we all should be doing, because it's where the future of Java is going. If it's not Quarkus, it's going to be some other GraalVM framework. But we should have all the information we need on build time, because if not, disaster happens.
Yep. All right. I don't see any more questions. So if you have any more remarks, or if you're call it a day. I know it's past probably dinner time for you.
Well, no, we have dinner very late on Spain, so don't worry about that. No, I was just going to say that I encourage you to try Quarkus, because for me, I wanted to just use the fancy new technology, and I discovered something that I really liked. Dynamic invoke. Can we use dynamic invoke in Quarkus? That's calling I'm going to call this class, the method called blah, blah, blah on this class called blah, 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 right? I would say no, you cannot do that. That's kind of reflection. You can, if you need to do something like that, probably you need to use a different design pattern, maybe a facade or something that is not calling dynamically something. if you really need that, maybe Quarkus is not your framework. But I would argue that there's always another way of doing this kind of things.
All right, excellent. All right, I will go ahead and end the stream. Thank you very much, Maria, for your time. It's a very super interesting talk. You covered a lot of stuff, and a lot of stuff as a Quarkus user. I'm not a developed Quarkus engineer either, but I've used it quite a bit, and I've certainly run into some of those same things. So it definitely hit home for me as well. And read the docs, RTFM, like what people say.
Yes, please read the docs. Don't be me.
Excellent. All right. Thank you very much.
Thank you.